Okay, students. Now, if I took three numbers, right? Like, let's just say 306 and 90, and I asked you to put all those together, what would you do? Well, you would, whoa, let's straighten these out a little bit. You would have a column for hundreds, and you have a column for tens, and you have a column for ones. So, would you write 300 here? Would you write 90 here and you write 6 here? No. You don't need those zeros. Because once you put the number in the column, you know that the first column has no zeros. You know the second column has 1 0. You know the third column has 2 zeros. Well, wait a minute. So wait, the ones has no zeros, right? The tens has 1 0. The hundreds has 2 zeros. Now, if any number has no zeros at all, what that means is that you had an exponent actually here. The base is 10, but the exponent is 0. If you had 1 0, because anything here would just be 1. If you had 1 0, then that means that you had 10 to the first power. See? That's how you wound up with tens. If you had hundreds, then you had 2 zeros, right? Well, the exponent then is 2. That's how you wound up with 2 zeros. So if your exponent is 0, it's a 1. If your number is a 1, the exponent is 0. If the exponent is 1, then you have tens. If your exponent is 2, you add hundreds. So what happens if your exponent is what if we added another number to this, like 5,000? Well, you'd put a 5 right here. And, the thing is, you'd have 3 zeros. What does that mean? Well, if I have 3 zeros, then that means the exponent is 3. That's a base 10 system. That makes sense. You've heard the word base 10 system before, and it's been, when you were a kid, or you might have done like some little history project and they talked about, different civilizations and what type of system they had. Base 10, we have a base 10 system, which means that all numbers that we have, all these columns that we have, ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, is all based off of exponents. If we have ones, what that really means is that in our base 10 we don't have an exponent. If we have tens, what that means is in our base 10 we have one exponent. If we have hundreds, what that means is if we have base 10 we have two exponents. If we have thousands, what that means is we have 3 exponents. So let's kind of rewrite that a little bit. So if I had ones, so tens, hundreds, thousands. Pretend that's the word thousands, kids. 100,000s. Millions. So if I had a 1, that means I have no zeros. Here I have 1 0, 2 zeros. That's how you know the difference, right? And I guess if I had digits, that could count as well. So I guess I could just say no zeros, but I've got one number. Or I have two numbers. Or if I have hundreds, I have three numbers. Or if thousands, I have four numbers. But I really don't need that because I'm only just talking about place value right now. So let's kind of leave this for now. Let's just stick with zeros. So what does that mean if I had, what does that really mean? What it really means is if I've got ones digit, I have no exponents at all. So like if I had the number 6, what that really means is 6 times 10 to the 0 power. And 6 times 10 to the 0 power is just like 6 times 1. So what does tens mean? Well, if I've got like 3 tens, what does that really mean? It means I got a 10 with one exponent. So if I have tens, what I really have is 3 times 10 to the first power, and that's the same thing as saying 3 times 10, and that's 30. You know, for hundreds, what that means is the exponent's 2. So if I had like 4 times 10 to the second power, well, that's saying 4 times 100. So that's 400. And I can just keep going on and on and on. And it really doesn't matter because I'm allowed to multiply exponents with variables mostly because we know how to multiply with exponents. We've always been able to do this. We did this without really having to tell you, which was kind of cool if you think about it. I mean, I'm showing this to you, and even now, you may not completely understand what I'm talking about. And you didn't have to. You know, you could still multiply anyway. You know, this is more or less just for your added benefit. If you could understand this, I mean, this is really cool. Oops, too many zeros there. It's really cool information to, like, it could really help some of your understanding. And then even when you get to millions, you get 10 to the 6 power. You know, if you had a number like 8, well, that's just because you had 6 zeros. Well, how'd you get the 6 zeros? Well, you got 6 zeros because really what you're doing is we're only allowed to count up to 9. You know, and then once we get past 9, then we have to increase our base. See, if we go 1, 2, 3, 4, 5, 6, 7, 8, 9, then we get into the tens. Well, we're still just going back to 1 again. When we're counting tens, the base has to change from no zeros to 1 0. You know, when we count tens, 1, 2, 3, 4, 5, 6, or 10, 20, 30, 40, 50, 60, 70, 80, 90. You know, once we get to 100, we have to go back to 1 again. And we have to change our base to 2. 100, 200, 300, 400, 500, all the way up to 900. When we get to that, you know, we have to start back at 1 again. We have to change the base now to 3. I'm sorry, we have to change the base to 3 tens. So 1,000, 2,000, 3,000, 4,000, and we just keep going on and on and on. I mean, this is really the idea behind a base 10 system. You know, we really don't count forever. You know, that's not really the idea behind this. We only count up to 9, and then if we have to, we can change the base. This is the idea behind abacuses and every other counting instrument. That's what enabled us to use binary code. That's what enabled us to set up all the algorithms for calculators and computers and everything else. So why exactly am I showing this to you? Because when you're multiplying, you multiply off a base 10 system. See, see, if I break this up into columns, this will begin to make some sense. So when I've got multiplying like 23 times, I don't know, 71. Okay? See this? 3 times 1 is just 3. Well, how did I know that? Well, I've got 3 numbers without a base 10, and I got 1 number without a base 10. That was pretty easy. Now, what happened? Now, I've got 2 numbers with a base 10. One of them, that's a tens column, and one without. So it's a 2. You know. Now I'm not counting ones anymore, so I'm not going to bother. 3 times 7, 21. Okay. But really what I'm counting is 3 ones times 7 tens. Just put a 1 and put a 2 up here. 2 times 7, 9. Add 2, 11. Okay, like I can do that. Because I know all my multiplication is based off of base 10. Off of exponents. It's off of exponents. And if multiplication is based off of exponents, then why can't I do the same thing instead of, 23 times 71, why can't I do 2x plus 3 times 7x plus 1? I mean, wouldn't it be the exact same idea? I mean, they're exponents too. They're numbers too. It's still a base 10 system too. So why not? I mean, it should make the exact same sense. So I could just write 2x plus 3, and I could write 7x plus 1, and that's off of place value too. I mean, instead of, it being like, since ones is 10 to the 0 power, and tens is 10 to the first power, and hundreds is 10 to the second power, and thousands is 10 to the third power, then in this case, this is just going to be, x to the 0 power, and x to the first power, and x to the second power. It really doesn't make a difference. 3 times 1 is 3. 2x plus 1 is 2x. Add a 0. 3 times 7x is 21x. And 2 times 7 is 14. And x times x is x squared. Why is this any different? It's not. It's the exact same idea. It's all built off of base 10. And if that base 10 is built off of exponents, then I can still build this off of exponents too. And there's kind of the link between why you're able to multiply with variables the same way why you're multiplying the same with numbers. Because they both have a lot in common. They're both built off of exponents. So